Hello, Algebra 2 students. This is Mr. Kraft coming to you from my living room. We've been talking about manipulating things with functions, adding, subtracting, multiplying, dividing, composition of functions, which is a function of a function. What I want to talk to you today about is inverse functions. So we want to talk about inverse functions. The word inverse means opposite or reverse, doing the opposite of something. So, you know, the old thing when you're a little kid, opposite day. That's what we're doing today. This is opposite day. So, a function, a very, very informal way you could say a function is doing something to something. That's not very mathematical language. You might say, well, doing something to something, that could mean anything. And it could. But to use an example, I take just about the simplest example of a function I could have. Fx equals x plus 2. What does that mean? It means you have something, x means something, and you do something to it. You add 2 to it. So if x was 5, 5 plus 2 is 7. If x was 8, 8 plus 2 is 10, and so forth. That's all you're doing. If I said g of x equals 3x minus 4, that means I'm taking x, I'm multiplying it by 3, and then taking 4 away from it. So that's all a function is saying. A function means you take something, and by something I mean the x, and you do one or more things to it. In the case of fx, I'm only doing one thing to it, I'm adding 2 to it. In the case of gx, I'm doing 2 things to it, I'm multiplying it, subtracting from it. Okay, well, inverse is opposite. So an inverse function means I did something to something, now I want to undo that. A common sense example, my great artistic talent. If I decided to walk, say, 7 paces to the east, and then I walked 3 paces north, then I decide I want to return to where I started from. And maybe I'm walking in such a way that the shortest way, obviously, would be to go by the hypotenuse of this right triangle. But let's say there's something blocking me, I can't do that. Well, I went 7 east and 3 north. How do I undo that? Well, I go 3 south, which undoes the north, and 7 west. I just do the opposite. I go back to where I started from. So my net travel is 0. Now I have walked 7, 3, 3, 7, so altogether I've walked 20 paces. But the net, in other words, how it ends up, is as if I had stayed still. That's what we're doing with functions. So an inverse function, if I go 2 forward, I want to go 2 back. So concretely, let's go back and say fx. Well, I didn't mean to have that in red, but that's okay. So inverse, the way we write that is -1. This is like, I know you remember this from the physics, when we said like, say, the sine of a 45-degree angle, um, it would be 1 over the square root of 2, which if you rationalize it is the square root of 2 over 2, because it is the opposite side, which is 1 over the hypotenuse, which is square root of 2. Anyway, that's kind of beyond the point. inverse, if I gave you the number already, you're going back to what the original angle was. So that's what I'm doing here. It's not a negative exponent like a fraction. It means I'm going back. If plus 2 is what I'm doing to the x, what's the inverse of that? And it's obvious the inverse is taking 2 back off. If I add 2 to it, and I want to get back to where I started from, I'm going to take away 2. But let me show you how we do this formally. Recall fx equals y. It's exactly identical to y, in fact. So the way to find an inverse function, you first rewrite it in xy notation instead of the fx. Then you switch. You change your x to a y and your y to an x. Then you need to solve for y. So I'm going to flip this around. Y plus 2 equals x. Subtract 2 from each side. Y equals x minus 2. And the last step, I replace y with inverse function x. That is my inverse function. Now, let's prove this. So we said fx equals x plus 2, and we said inverse function is x minus 2. Now, really, that's kind of obvious. But we want to prove that this is correct. So if you remember, the other day we did composition of functions, where you did a function of a function. So to give a quick example, if I had f of x equals x plus 2, g of x equals 3x minus 8, and we said f composed with g, we say that just substitutes the g back into the x. So we have 3x minus 8. This is dropped in place of that, plus 2. And the negative 8 plus 2 is negative 6. So f composed with g of x is 3x minus 6. So what we want to do this time is we want to compose f and inverse f. And see if everything cancels out and I get back to just a plain x. Because the example we showed of the person walk over here and walk up there, then we said they undid their original travel. They went back this way and back that way, and so there was no net change. They ended up where they started from. By definition, the variable x is where you're starting from, so we want to see if it all cancels out, like the walking canceled out here. So what I'm going to say is I've got this is the inverse function. I substitute that back into x here. That's what composition means. So I get x minus 2, then plus 2. Those guys cancel, gives me x. So I say ding, 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 that is correct. That is my inverse function. Let's do a more complicated example. Let's say g of x equals 4x minus 7. Okay, once more, to get what we're looking for this time is inverse of g. We replace g of x with y, and we swap out our x's and y's. Now we have to solve for y. I'm going to flip it, and I'm going to add my 7 to each side. So that gives you 4y equals x plus 7. Then I divide everything by 4. And it's important to remember you divide each thing on the right side. That gives you y equals x over 4 plus 7 over 4. And then you rewrite it in function notation, and you get inverse function of x equals x fourths plus 7 fourths. Your answer. Let's prove that that is the correct inverse function for this. Let's erase. I just now realized I wrote f. I should use g because I'm using g of x here. We'll fix that in a second. Let's get all this stuff erased. So let's rewrite this as g, inverse g. So we've got gx equals 4x minus 7, and inverse g of x over 4 plus 7 over 4. So what we have to do is compose g with inverse g and see what happens, which means we take this and plug it in. So we have f times the whole, 4 rather, times the whole quantity, x over 4 plus 7 over 4, and then minus the 7. This is a distributive property, so I'm going to have 4 over 1 times x over 4 plus 4 over 1 times 7 over 4 minus 7. Your 4's cancel, so that leaves you x plus 7 minus 7. 7's cancel out, leaving you with x. So that is correct. Let me do one more slightly more involved one, and we'll call it good. Let's say h of x equals x squared plus 3. And we want to find inverse h. We do what we've been doing here before. We replace h of x, the function notation, with plain old y. And we swap out the y and the x. And then we solve for y. Y squared plus 3 equals x. Take 3 from each side. Y squared equals x minus 3. This time, in order to undo the power, we use the equivalent root. Take the square root of everything y equals x minus 3, and then you just replace that with inverse h equals x minus 3, square root of it. So let's prove that that works. So our original function, x squared plus 3, and our inverse function was square root of x minus 3. Once more, we're going to want to do composition of functions. H compose h to the negative 1 of x, which means we take this whole thing as is and sub it in here. So we get the square root of x minus 3, that whole thing squared. Now, this is not a difficult problem. The square of a root just undoes everything. It just clears out the radical, and you get x minus 3, and then plus 3 out there. Bam. Always better with sound effects. So, you're left with x. And that's what we wanted. That proves that I was correct in what I said the composition of functions was. The inverse function was there. Okay. All right. So hopefully that clarifies how this kind of thing works. Essentially, what you're doing when you're getting an inverse function, you're saying this function took me to a certain place. What restores me to the place I came from? And applications could be like industry, you're finding out a way to reverse a chemical reaction or a physical reaction, undo a particular thing. That's basically what's going on. I want to conclude by saying that I've not checked the email since I started making this video. As it stands now, we are shooting for a Zoom meeting for 8 a.m. on Friday, the 17th. And I'm going to make it a combined meeting for physics and algebra 2 and pre-calculus because all of you that are in the physics are in one of those other two. So it can be kind of a problem solving, brainstorming session for all those classes. We'll be doing it via Zoom, and I'm going to set up the meeting for that shortly. And it has a whiteboard. So instead of me making a video and then I post it, then you watch it later, I will be able to answer your questions in real time. Yay! So if there's anything you don't understand about this, please have your questions ready. I think that if we can make this work, it will be a great opportunity for all of us for you to ask me questions, to clarify things in a way that you simply can't with a pre-recorded video. I'm going to leave it at that, and I hope to see you tonight at the drive-through event over at Cal in real life, although socially distanced, 6 feet or more. And I hope to see you virtually via Zoom tomorrow.